Assalamualaikum and good morning to all of you. Welcome back to this video. This time I will discuss about tutorial 2.2, which is the frame analysis by considering the cantilever method. Okay, this is the question where you have to analyze the shear force and bending moment for the frame shown in the figure by considering the wind action. And in this tutorial, we will use the cantilever method. Okay, this is the action of wind load on the building of 4-story, and the building is supported by 4 number of columns, 1, 2, 3, and 4. So the first step of the solution is to determine the lateral action which will acting on the joints. So the first of all, we have to determine the value of WD, which is the factored load. Okay, in this case, the WD is equal to 4.2 kilonewton. And then we determine the value of lateral load, which is acting on every story joint. So at level number 4, the story joint is equal to 7.56 kilonewton. At story number 3, level number 3, the value of lateral load is equal to 15.12. And the value is similar for level number 2. And finally, at level number 1, the lateral load is equal to 16.38 kilonewton. Then step number 2 is to set up the point of contraflexure. So for the beam, this is the point of contraflexure, which is yellow color, which is located at the middle of every span. And for the column, I make it as a green color, which is located at the middle of the column height. Okay, then we can label the joint by using alphabet like A, B, C, and D. Okay, next, we have to determine the axial load acting in the column. First of all, we calculate the distance of X, which is the distance from the first column. Okay, this is the first column. I label with K to the neutral axis. This is the neutral axis. So we can determine of the value of X by using these equations. Okay, LKL is equal to 6. This is the LKL or L1. And then LKM is the distance from K to M, okay, which is 11 in this case. And then LKN is the distance from K to N, okay, which is 17. And then we divide by 4, which is the number of support. So the X is equal to 8.5 meter. Then we have to determine the ratio of axial force in every column. Since this in this case, the frame are exposed to the lateral load, so the columns near the source of lateral load will experience the tension, and the column beyond the neutral axis will experience the compression. Okay, so be careful with the signage of the loading. Then we can calculate the ratio of axial load by using this method, where for the distance of column K to the centroid is equal to 8.5 meter. So this is the centroid, and then this is the distance, this is the location of column K, so the distance is equal to X, which is equal to 8.5 meter. And then the distance of column L to the centroid is equal to 2.5 meter, which is similar to the distance of column M to the centroid. And column N to the centroid is equal to 8.5 meter. So the ratio for axial load of every column, we can use this method. 3.4 is actually from 8.5 divided by 2.5. And then we get 3.4. So this one, 1.0 is 2.5 divided by 2.5. Yes. Okay, next is the analysis on level A and above. Okay, which is step number 4. So this is our frame. And then we just focus on level A. Okay, this is level A and above. So this is our subframe. Okay, next, we have to consider the axial load on column. Okay, this is 3.4 P. Okay, and then at the middle is 1.0 P. Okay, next, we can determine the value of P by considering the moment at A. Okay, so the cumulative moment at A must be equal to 0. So we can solve this equation. Okay, this is the equation of equilibrium. Okay, we consider the forces and then the distance. This is the L4. And then we consider also this one, the forces and the distance. Okay, this action will create positive moments because this is clockwise, and also this one is counterclockwise, and this one, okay, and this distance is also counterclockwise, and we sign as negative. So we settle this equation. The value of P should be around 0.22 kilonewton. And so this is the axial load in the column for column K, L, M, and the last one is N. Okay. Next, we draw the subframe to be like this one. Okay. We consider the axial force in column we calculated before. And next, we draw, this is the forces, the F1, F2, and F3 is the shear forces in the beams, and the H1 to H4 is the shear force in the column. Okay. Then we consider the subframe to the left of F1. Okay, so this is F1, and then we consider the subframe to the left, this is to the left. So we consider this subframe only. Okay, to be this one. We extract out, okay, to ease our calculation. So this is our subframe, and we solve the equation of equilibrium. So the summation of forces, vertical forces, shall be 0. So F1, this is the F1, and it has to deal with the column axial load, which is 0.75 kilonewton downward. So this one is negative. So F1 is equal to 0.75 kilonewton. And next, the H1, we can obtain the value of H1 by consider the moment at F1 equal to 0. So we play around with the forces and the distance. Okay, this is H1. H1 multiplied by L4, and then 0.75 times L1 over 2. Okay, it must be 0. So H1 is equal to 1.25 kilonewton. Next, we consider the subframe to the left of F2. Now we consider the F2, which is located here. We must extract out this subframe only. Okay, so it will be like this one. And we consider this figure for analysis. So the equilibrium equation, we obtain at F2 equal to 0.97 kilonewton. And by considering the moment at F2 equal to 0, we can obtain that the H2 is equal to 2.6 kilonewton. Next is we consider the subframe to the left of F3. So this is the F3. We consider to the left. Then we only consider this part of the subframe. So it will become like this one. Then we solve the equations of equilibriums to get the F3 and H3. So the F3 is equal to 0.75 kilonewton, while the H3 is equal to 2.6 kilonewton. Okay, next. I hope you know how to derive this equation, which is based on the forces and the distance. Okay, and then this is the point of considered moment. Okay, if the moment is clockwise, so it's positive. If the moment is counterclockwise, like here, it's 0.22 times the L2 plus L3 over 2, okay, which is this one. So we mark it as negative. Okay, next, we consider the whole subframe and we use all the data obtained before, which is, in this case, we use the value of H1, H2, and H3. Then we consider the summation of horizontal load, okay, which involve the 7.56 kilonewton and involve the H1, H2, H3, and H4. We obtain that the value of H4 shall be equal to 1.11 kilonewton. Next, we can provide the shear force diagram based on the results of the previous calculations. Okay, so for the frame of level 4, okay, which is based on joint which is from point of contraflex shear of level A before, this is the value of shear force. And this is the diagram. Is 0.75, 0.75, which is equal to F1 and F3, and 0.97 is equal to F2. And the green color here is representing the shear force obtained in the column. Okay, next, this is the bending moment diagram. Okay, from the shear force diagram, we can calculate the bending moment diagram. Let's say for the beam, this is the value. So how I obtain the value of 2.25 is actually from this one, from this shear force and then the distance. So 2.25 is equal to 0.75 times the distance and then divide by 2. Okay, let's say this is 2.43 is equal to 0.97 times 5.0 divided by 2. Okay, next, for the column, this is the value of bending moment. A similar method, okay, let's say for this value, 4.68. 4.68 I obtained from considering this value of shear force, 2.60 times the distance or the column height, 3.6 divided by 2. Okay, next. Okay, we move to the step number 5, which is the analysis on level B and above. So now we consider from top part of the building to the level B. And then we extract the subframe like this one. And then we consider the axial load from axial load in the column. Okay, so we simplified our structure, our subframe like this one, and then we consider the moment at B equal to 0. Okay, I hope you can derive these equations based on all these relevant forces. And then you can obtain the value of P shown equal to 1.10 kilonewton. And then this is the value of axial forces in other columns. Okay, next, we complete the diagram for analysis. Okay, this is from previous analysis, okay, which is from step number 4. Okay, so we have to match with the lower level, which is a level B and above. Okay, this is level number 3. Next. Okay, so we have to consider the value of axial force from upper column. Okay, but be careful with the direction. We change the direction. Okay, and then this is the value of axial force, axial load in the column we calculated just now. Okay, and then make sure the direction is similar to the earlier stage. Okay, which we consider that column K and L will experience the tensions, and column M and N will experience the compression. Okay, so this is the shear force for beams, and the H1 to H4 is the shear force for columns. And then we use the data which is we obtained from previous calculations. Okay, it will acting at the upper column. Okay. Next, this is the final diagram that we have to consider. And as previous, we have to consider subframes. Okay, so we have to extract out the subframe, which is from F1 and to the left. So it will become like this one. So we have considered this subframe only in the analysis. So we solve this problem. We solve the equation of equilibrium. F1 is equal to 2.99 kilonewton, and the H1 is equal to 3.73 kilonewton. Next, we consider the subframe to the left of F2. This is the F2, and this is the subframe to the left of F2. We only consider the subframe, so we can neglect the others, and also we can neglect the F1. Okay, so this is simplified. So then that we can only focus to this subframe only. So the value of F2 is equal to 3.87 kilonewton. We neglect the F1 here. And then the value of H2 is equal to 7.76 kilonewton. The value of H1 here is 3.73, which is from the previous calculation. Okay, next, okay, we consider the subframe to the left of F3. Okay, so like this one, we only consider this subframe, no F1 and no F2. So the value of F3 shall be equal to 2.99 kilonewton, and the value of H3 is equal to 7.76 kilonewton. Okay, by solving this equation, I hope you know on how to develop these equations, because it's quite complicated since we have to deal with so many forces and so many distance. Next, we consider the whole subframe to settle the value of H4. So, based on this equation, the value of H4 shall be equal to 3.43 kilonewton. Okay. Next, finally, we can draw the shear force diagram based on the results. Okay, so this is the shear force diagram for the beam. Okay, which is similar to the value of F1 to F3, and then the shear force, the shear force in the column is equal to value of H1 to H4. And then we can provide the bending moment diagram. Okay, just a similar method as I showed before in the step number 4. So this is the bending moment diagram for beam, and this is the bending moment diagram for the column. Okay, next, we can move to step number 6, which is the analysis on level C and above. Now we focus on level C and above. So we can extract the subframe like this one, and we consider the axial load from in the column. So we can find the value of P for this case, which shall be equal to 2.82 kilonewton. And then this is the axial load for all columns. Okay, then we draw the diagram as this one. Okay, this is from previous steps. Okay, this is from step number 5. Okay, this is from previous calculations, and this is also from step number 5. And we have to find the value of F and H. Okay, so we just conduct the analysis for every subframes as shown in step number 5 before. Okay, which we have to consider the subframe of F1 to the left to obtain F1 and H1, and then we consider the subframe of F2 to the left in order to obtain the F2 and H2, and then we consider the subframe of F3 to the left in order to obtain the value of F3 and H3. And then we consider the whole frame to calculate the H4. So the final result is like this one. Okay, next, this is the shear force diagram and the bending moment diagram for level C and above. Okay, next, we do the step number 7, which is the analysis on level D and above. Okay, we consider this subframe and also consider again the ratio of axial force in the column. Next, okay, we arrange our diagram like this one. And then we consider the moment at D equal to 0. We develop these equations. Be careful because the number of forces is now increased. Okay, you have 7. 1, 2, 3, 4, 5, 6, 7. 7 number of forces means we also have 7 distances. So you have to be careful. And the value of P is equal to 5.71 kilonewton. Okay. Then we can redraw the diagram to be like this one. Okay, so this is the value of axial force in column from step number 6, and this is step number 7, which we calculated just now. And this is the value of axial force in column we obtained from step number 6 before. So we conduct this analysis for every subframes as shown in step number 5. Okay, which we consider one by one. The subframe of F1, subframe of F2, and subframe of F3, and then we end up with the whole frame to obtain the H4. So this is the final result of the shear force in the beam and column. So this is the shear force diagram for the beam and column, and this one is the bending moment diagram for the beam and column. Okay, next, the final step is the final shear force diagram and the final bending moment diagram. So we can combine for all levels to be like this one. Okay, and then this is the shear force diagram, and this is the combination of bending moment diagram for the whole frame. Okay, that's all for this video. Thank you very much for your attention. I hope you can try by yourself. Never give up. Keep trying. Assalamualaikum. Bye bye.